Hello. So, this video we are going to be introducing exponential functions, sort of what they are, how we notate them, and what they're sort of classically useful for. So, exponential functions, what are they? Exponential functions, they are these things of the form b to the x, where the b is some constant and the exponent, I say x here, but really it's sort of anything with a variable. It can be a whole bunch of different stuff in there. So in particular, we have this sort of b to the x form, and then that b is some base. Now, the base is a constant, right? It's sort of redundant, it's a single constant, but I want to drive home the idea that it really needs to be just a number. Now, that number could be something that is sort of a weird number, right? You can have bases that are like the square root of 7, or you could have a base of e or something, which we'll talk about a little bit later. But it is really, honestly, just some constant number. That's it. Now, in contrast, the power, right? We have x here, but it can be any kind of function. So as long as it has the sort of independent variable in it, that's the important part. So, for example, we have stuff like 3 to the 3x plus 1, right? So this would be an example of an exponential because the base, right, is that the purple part here is 3, and the power has the independent function, the independent variable in it, right? Likewise, 4 to the 17 minus 2x. This would be another exponential function, okay? Now, in contrast, sort of the most common thing that students mix up when they're trying to sort of remember exponential functions and their various, what is an exponential function? It's very easy to get the sort of nature of these numbers switched, meaning that instead of having a constant to some sort of variable like b to the x, they might see something like x to the n, right? So to be clear here, this, right, if I have a base that is a variable and the power that is a constant, this is not an exponential, right? So this is a polynomial, or potentially polynomial, depending on whether that constant is sort of a whole number. But the key thing here is that this is not an exponential, right? Exponentials need to have the variable in the power, and the base has to be constant. Can't go the other way, okay? All right. As mentioned, e, right? This is a sort of special constant that is some irrational thing like pi. This thing, it turns out that in calculus in particular, this exponential function e to the x, this thing has a whole lot of really special properties and in fact has its sort of own special role in calculus. So although it's sort of a weird number in some sense to start with, it turns out it's a lot more natural than you might think, but we'll get to there sort of later in this section. Nonetheless, it might seem like a weird number to choose, this weird e, but nonetheless, because it's so important, especially in calculus, we're going to be doing sort of a lot of stuff with e to the x. We're going to sort of hammer that one in particular a lot in this class, by virtue of the fact that it's a pre-calculus course, right? Like the whole point is to be ready for calculus. So we're going to see e as a base a bunch because we want to sort of get used to that idea, okay? So just forewarned is forearmed, I guess. Just know that that's going to show up a bunch. All right. Now, in terms of what exponentials actually are, right? It's one thing to be like, okay, here's how we write it and all of these things. But in terms of what they actually are from like a modeling or geometry standpoint, exponential functions have this sort of key property that they change over time, but how they change, it's always relative to their current size. So instead of, for example, squaring the number you always have, right? That would be like a polynomial thing, like x squared. Instead, it's more like the next sort of cycle in some sense, increasing the exponent by 1 might do something like double its current value, right? Where it sort of depends on its current value as to what ends up happening. And in fact, because of this, the fact that it sort of changes based on its size, it ends up having this like really important property that it makes them sort of some of the simultaneously fastest growing functions. So in some sense, they can sort of take off really fast. But at the same time, they can also be some of the slowest decaying functions, meaning that they can sort of come down quickly, but then start really going down super slow over time. And so the sort of reasons for this is stuff that we're going to get into in other videos, but this is sort of the motivation for why we want to learn about and study these things from a more sort of modeling standpoint. Okay? All right, so what do we do? Well, we introduce the idea of the exponential function, this idea of having some constant value raised to a power where that power has the variable, right? So e to the x, 2 to the x, pi to the x, these things would all be some sort of exponential. And in fact, we can even have sort of complicated exponents in there that have sort of other stuff happening, but as long as they sort of change with the variable. So you could have something like, say, pi to the 3x plus 1. That would be an exponential function. The other thing we talked about, though, is this, well, e being sort of a special case, right, where that's going to show up a lot because of sort of mystical properties in calculus, which, we'll talk about a little bit in this, but mostly you'll learn about that in calculus. But we really wanted to sort of mention that it's easy to sort of mix that up with polynomials, right? To be like x to the n versus n to the x or whatever, right? Like how different is that really? Turns out it's very different. So make sure that you sort of don't conflate those two. Don't mix them up, right? And last but not least, we sort of hinted at this idea that exponentials are really important when we come to talking about things growing over time. And again, this is something that we're going to sort of touch on in future videos and things. So they have really useful properties when it comes to how things grow or decay over time. Okay? So that is that.